Yesterday we looked at equally likely events for chance experiments, but today we're going to look at chance experiments with outcomes that are not equally likely. So we learned that when the outcomes in a sample space are equally likely, the probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. However, when the outcomes in the sample space are not equally likely, we need to take a different approach. So let's go ahead and look at this problem. Luis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. So we have 4 different questions that we need to answer. So I'm actually going to break up my page into 4 pieces so that I can make sure I answer every single one. So question 1, question 2, question 3, and question 4. Please do this on your notebook as well. And so we're going to look at question 1 first and then go down the line. So the first part says to find the probability that Luis receives 3 or 4 phone calls. So if we're going to find the probability of him receiving 3 or 4 phone calls, let's first look at our table. So I see with my highlighter that 3 or 4 phone calls is right here. And the probability of each of them happening is 1/3 and 1/9. So 1/3 and 1/9. Okay, well, how would I find the probability of both situations happening? Well, we would need to combine these probabilities together. But if these probabilities are fractions, how do we combine them? Well, I remember that before we add any fractions together, they need to have common denominators. So how can I make a common denominator if one is a 3 and the other is 9? Well, we want to know what factors these numbers have in common. So you may already know this off the top of your head, but some of us may have some trouble seeing what numbers they both have in common, what multiples. So I'm going to set up a table with my denominators. So I have 3 in my table and I have 9 in my table. So I'm going to just count my multiples of 3. So 3, 6, 9. That one seems pretty close to another number I see on our table. And I'm going to do the same thing with 9. So 9, 18, 27. And actually, I don't need to have even gone even further than 9 because I now want to circle where I have numbers that are the same or in common. And so I see that they both have 9. So I can stop here and see that if we have 1/9, that is perfect. We can make 1/3 have a denominator of 9 because these are the same multiples. They have the same factor together. Now, how would I need to get 3 to 9? How would I multiply 3 to get to 9? 1, 2, 3. It would be 3 times, which again, we should know this off the top of our head. But if we didn't, that's how we can use our table to review. And remember, we have to multiply the top and the bottom by 3 in order to keep them equivalent and equal. And I see that 1/3 is the same as 3/9. And so now, because these have the same denominators, now we can add them together. And so I know 3/9 plus 1/9 equals 4/9. Perfect. So the probability that Luis receives 3 or 4 phone calls is 4 out of 9 times. Now, again, we can convert this to a decimal, we can convert this to a percent, but since the situation has given us all fractions, I'm going to leave them as fractions for today. Alrighty, so we have done the first one. Now we are going to look at part 2. So if I look at part 2, it is telling us to find the probability that Luis receives fewer than 2 phone calls. Okay, so if I'm thinking about numbers that are fewer than 2, I know that 0 and 1 would be included. Now here's the question. Would 2 be included? Is 2 fewer than 2? No, it is equal, so we cannot include it. So I'm going to go ahead and highlight this part of our table because we are looking at only these 2 probabilities. And I see that these 2 probabilities are 1/6 and 1/6. So if I'm going to combine those together or add them up, they already have the same denominator. So I can go ahead and add, and I get 2/6. Now, this probability is fine to stay the way it is, but we also know that we can simplify because I know a number goes into both 2 and 6, which is actually 2. So let me go ahead and use that so I can simplify. So I see that the probability of receiving fewer than 2 phone calls is 1/3. So we have 4/9 and we have 1/3. Alrighty, moving right along. So if we look at part 3, it says to find the probability that Luis receives 2 or fewer phone calls. So now if we just did fewer than 2 phone calls, but if they are now saying we can receive 2 or fewer, does that include 2? Yes, it does. So now we can actually include 2/9 into our total. So we already had 1/3 from the earlier part, right? That's the fewer than 2 phone calls is a probability of 1/3. And now we need to add 2/9. Sorry, let me put my addition so we know that that's what we're doing to combine them. We are adding them. But again, do these have common denominators? They do not. But luckily, we already found the common denominators up here, so I can rewrite this as 3/9 plus 2/9, and now we can add them together by adding those numerators on the top, and we get 5/9. So this probability can't be simplified, so we are going to keep it as 5/9. So the probability of Luis receiving fewer than 2 phone calls was 1/3, but then the probability that Luis receives 2 or fewer phone calls is now 5/9. So that is number 3. And now we can move to part 4, where it says find the probability that Luis does not receive 4 phone calls. So what does that mean? Well, if we look at our table, we can include any number that does not include the number 4. So that would be 0, 1, 2, 3. These 4 probabilities right here, anything but the number 4. So I'm going to write these down here below. So 1/6 plus 1/6 plus 2/9 plus 1/3. Okay, so we already know what this probability is. We got this again up here, and that was 1/3 plus 2/9 plus 1/3. We're just bringing them down. And then we already know that 1/3 plus 1/3 rewritten with a denominator of 9 is 3/9, just like we figured out in the first part. So I'm going to rewrite that. Excuse me. And so now they all have common denominators, so we can go ahead and add the numerators together. So 3 plus 2, which is 5/9, plus another 3/9 will get us 8/9. So again, adding the numerators together. And we can't simplify this fraction, so we're going to leave it here as 8/9. So as we look at all 4 of these problems, our stamp is really to make sure that when we are combining probabilities that do not have equally likely events, so in other words, with different denominators, then we need to make sure they have the same denominator first before we combine them. So our process is still the same like we learned yesterday and in previous lessons, but we do have to remember that denominators need to be the same before we add them. Let's try some more on our own.